What if I told you we could make Unreal Engine feel the rain? Not just particles falling from the sky, but puddles and surfaces that get darker and wetter in real time. Today, I'm building a complete rain system from scratch. Niagara rain, splashes, puddles, and even global wetness you can control with one slider. Let's dive in and make your worlds come alive. Here I've created a new project in Unreal Engine 5.6, and the first thing I'll do is make a new folder called Rain System. Right-click, go to FX, and select Niagara System. Now at the bottom left, click to create an empty Niagara system. Let's name it NS_Rain System. Double-click to open it. Inside the empty graph, right-click and choose Add Emitter. Then, at the bottom left, click Add Minimal Niagara Emitter. Let's name it Rain, just to keep our system organized. Now we have to add the spawn rate module to the emitter update. Click the plus button next to emitter update and search for spawn rate. Set the value to 5,000. This is required because it controls how many particles are created every second. Here we have a preview window that shows the result of each module. But instead, I'll add this rain system to our viewport so you can see the results happening in real time. I'll adjust the Niagara system window so both the viewport and the system are clearly visible. Now let's build the full rain system. Next, click the plus button next to particle spawn and search for shape location. This will let us adjust the shape of our rain. By default, the shape primitive is set to sphere, but for rain, it's better to use box. So here, change the box size on the X and Y axis to 6500 and leave the Z axis as it is. As you can see, we now have a lot of rain particles spawning in the viewport, but they're a bit too big, so let's fix that. Go to the Initialize Particle module under Particle Spawn. In the Sprite attributes, change the sprite size mode to Random Non-Uniform. Then set the minimum size for the X-axis to 0.1 and the maximum to 1. For the Y-axis, set the minimum size to 10 and the maximum size to 50. And now the particles actually look like rain. Make sure to save the system at this point. Now we need the particles to fall like rain. Under Particle Spawn, click the plus button and search for Add Velocity. If you see an error, just click Fix Issue, which says Add New Dependency Module Solve Forces and Velocity. And that will fix it. With Add Velocity module selected, click the drop-down arrow and choose Random Range Vector. This lets us set minimum and maximum values for each axis. For the Y-axis, set the minimum value to 400 and the maximum to 900. For the Z-axis, set the minimum to -900 and the maximum to -1200. Now we can see the rain falling, but it's not aligned with the velocity. To fix that, go to the sprite renderer and change the alignment from automatic to velocity aligned. Now go back to the Initialize Particle module and change the lifetime from 5 seconds to 2. This is important because a shorter lifetime makes the rain disappear more naturally instead of particles hanging around too long and breaking the effect. Right now, the rain is passing through the floor because there's no collision. To fix that, go to Particle Update and search for collision. Once you add it, you'll see in the viewport that the rain collides with the floor, but it's also bouncing and flying around. First, change the particle radius scale from 1 to 0.1. Next, add a Kill Particles module under Particle Update. Click on the drop-down arrow, search for Collided, and then select Has Collided from the Particles library. Now all the particles will disappear when they hit the floor or a wall. The next thing we need to create is splashes. So whenever the rain hits the floor, it will generate a water splash. Right-click on the system graph and add a minimal emitter, just like we did before. First, let's name this emitter Splashes. Before making changes here, go back to the rain system and add a collision event module. Once you add it, you'll see an error. To fix it, click on Properties and enable Requires Persistent IDs. Now select the Splashes emitter, click on Stage and choose Event Handler. Here we have a new module. First, set the source to collision event. Next, change the execution mode to spawned particles and set the spawn number to 10. Now, whenever the rain hits the floor, it will generate 10 small particles that look like a splash. Click the plus button next to Event Handler and search for Receive Collision Event. You'll notice a large sphere appear as the collision in the viewport, but don't worry. Go to Initialize Particle again and change the sprite size mode to Random Non-Uniform. This time, set the X-axis minimum to 0.2 and maximum to 1. For the Y-axis, set the minimum to 2 and the maximum to 3. Next, add a velocity module under Particle Spawn. Don't forget to click on Fix Issue, just like we did for the rain emitter. It's the same step here. And now change the velocity mode to Incone and set the value to 155. We also need to set gravity for our splashes. Go to Particle Update, search for gravity force, and add it. If you see an error, just click on Fix Issue to resolve it. Now change the gravity on the Z-axis. By default, it's set to -980. Change it to -380. I think this value works fine. Once again, change the sprite renderer alignment from automatic to velocity aligned. And go to Initialize Particle and change the lifetime value from 5 to 0.25, so the splashes don't look unnatural. Save the rain system, zoom in on the viewport and confirm the rain and splashes are working correctly. Now let's build Puddles and Wetness. That's essential for making the rain look realistic. Now if we want, we can create a new material, but instead I'll open the floor material and go to its parent. Here the first thing I'll do is create a Puddles mask. But before adding any nodes, let's import a texture that we'll use for our mask. This process will be the same for any material, even the master materials from Megascans. If you have any questions after watching the video, feel free to drop a comment or DM me on Discord. First, right-click on the material graph and search for World Position. From the XY pin, drag a wire and search for a multiply node. This will help us control the tiling of the puddles. Now we need one more multiply node. Drag the output from the first multiply and connect it to another multiply node. Drag and drop our texture into the material graph, then connect the multiply output to the UVs of this texture sample. Now set the first multiply node value to 0.01 and the second multiply node value to 0.3. We also need a vertex normal WS node. This node is required because it gives us the world space normal direction of the surface, which helps in blending the puddles more naturally with the floor. After that, add 2 constant 2 vector nodes and 1 constant node. You can add these nodes by right-clicking and searching for them, or use shortcuts. Hold the number 2 on your keyboard and left-click to add a constant 2 vector node, and hold the number 1 and left-click to add a constant node. For the first constant 2 vector, set the first value to 0.00001 and leave the second at 0. For the second constant 2 vector, set the first value to 0.1 and the second to 0.25. Finally, set the constant value to 1. Now let's add a lerp node and connect these constant nodes to it. We combine them with a lerp because it lets us smoothly blend between 2 sets of values, which helps control how the puddles appear and transition on the surface. Now drag an output wire from the lerp and search for mask. Add the component mask node, then duplicate it. On the first mask node, uncheck G in the details panel, and on the second mask node, uncheck R. Connect the output from the lerp node to the G mask as well. Now go to the texture we imported and drag a wire from the G channel. Search for subtract and add the node to graph. Attach the G mask node to the B input of that subtract. Next, add a divide node. Connect the subtract output to the A input of the divide and connect the R mask output to the B input. Now that part is done. Next, we need to merge the vertex normal WS node. Oh, I just noticed I added the wrong node earlier. So let's delete it and add the correct vertex normal WS node to the graph. Drag the output from this node and add a component mask. Uncheck R and G and check only B. Next, drag out the output from this mask node and search for saturate. The saturate node clamps the values between 0 and 1 so we don't get any unwanted negative or overly high values. Let's add the saturate node to our texture samples divide node. Now go back to the vertex normal saturate node, drag the output and search for power. Set the exponent value to 40. Then drag the output from the saturate and search for 1-. We use the 1- node because it inverts the values, turning white areas into black and black areas into white, which helps us flip the mask so the puddles appear in the correct spots. Now use a multiply node to combine the mask with the vertex normal world space. Drag the output from this multiply node and connect it to another multiply node. Leave the value at its default. Now drag the output from this node and add a saturate node. Connect this to the normal input of our material. Click Save, and let's see how the mask appears on our floor. Now we can see there are tons of puddles on the floor, but they don't have any water yet. We'll add that soon. Also, this material doesn't have a normal map, which is why the puddles look black. To fix that, add a constant 3 vector by holding the number 3 key on your keyboard and left-clicking. Then set the blue channel value to 1. Right-click on the graph and search for a lerp node. Connect the vector 3 node to the A channel and connect the saturate node from our mask to the alpha. Finally, attach the output of the lerp node back to the normal input. Now we have wet areas showing on the floor. We currently have tons of small puddles, but if it's raining constantly, the puddles should be much bigger. So, go to the constant we created for our masks and change its value to 0.5. Then, for the first multiply node on the UVs, change the value to 0.001. This will give us large puddles across the floor. This time I showed you how to build a mask directly inside a material. Now, let's create the puddles water with a wind effect. To keep things clean, I'll make it as a material function, so we don't end up with tons of nodes scattered around the material. And now right-click in the content browser, go to Material, Advanced, and select Material Function. Name it mf_wind, or water puddles if you prefer. Now double-click to open it. First, we need an input. Right-click, search for input, and add a function input. Then change the input type to function input scalar, and we can name it wind. Now drag the output and search for saturate. This will clamp the value between 0 and 1. Next, drag out the pin from the saturate node and add a lerp node. Connect the output to the alpha input. Break the link from the A input by holding Alt and left-clicking on it. Then set the A value to 0.2 and the B value to 0.5. Now that we have an input, let's create the animated normals for the puddles. Right-click and search for world position. Drag out the XY output pin from world position and add a component mask. Duplicate this mask and connect the world position output to the new mask as well. On the first mask, uncheck G, and on the second mask, uncheck R. This way, we can control the X and Y axis separately for our puddles animation. Drag a wire from the R mask and search for Append Many. Connect the R mask output to the R and B channels, and connect the G mask to the G and A channels. We do this to pack the X and Y axis data into multiple channels, which helps us drive the animated normals for the puddles more effectively. Drag the wire from the RGBA output and search and add a multiply node. Now we need a constant 4 vector node. Hold the number 4 on your keyboard and left-click to add it. Set the values as follows: R to 0.015, G to 0.013, B to 0.007, and A to 0.018. Then connect this constant 4 vector node to the B input of the multiply node. Right-click and search for a time node, then add it to the graph. Drag the output from this node and search for a multiply node. Now duplicate the constant 4 vector node and set the values as follows: R to 0.4, G to 0.02, B to -0.2, and A to 0.4. Then connect this node to the B input of the multiply node. Now we need to add both multiply nodes together. Drag the pin from first multiply node and search for add node and then also connect the other multiply node to this node's B input. Drag the output from the add node and search for the component mask. After adding it, duplicate the mask. On the new mask, uncheck R and G and check B and A instead. We've got everything set up for the animation. Now we need a normal map for the water. Right-click and search for texture sample. In the Details panel, click on Texture and search for water. You'll find a texture called water_n, which comes with the Unreal Engine starter content, so you don't have to download it from Google. Duplicate the texture sample, connect the first mask to the first texture sample UV's input, and the second mask to the second texture sample UV's input. Now comes the hardest step, that is merging the both normals. For that, right-click and search for Append. Now connect the R and G channel outputs from the first normal map to the Append vector node. Then duplicate the Append node and do the same with the R and G outputs from the second normal map texture. Drag the output from the Append node, search for an Add node, and then connect the outputs from both nodes to this new node we just added to the Material function. Everything looks good so far. Now search for a Multiply node. Connect the output from the Add node to the B input, and the output from the Lerp node to the A input. And now duplicate the Multiply node. We also need the blue channel from our normal maps. That's because the blue channel represents the surface's up direction in a normal map, and without it, the water normals won't look correct or realistic. Now let's merge everything using an Append node. Connect its output to the function output result, and now we can see our normals animating in real time in the preview window. Let's also rename the output result node from result to normal. Now our animated water puddles are ready to use in the material. Save it, and then close the window. Reopen the floor parent material and add the material function there to bring puddles into the scene. Make the material editor window smaller, then drag and drop the material function into the graph we just created. If you remember, we created the puddle mask earlier and added a lerp node where we left the B input on default. Now we can connect our material function to the B input of that lerp node. If you see an error here, it's because our wind input is empty. To fix it, add a constant node and set the value to 1. After applying, you might still not see any puddles. That's because the material color is gray and the puddles are a similar shade. So let's change the base color of our material. I'm changing the material color to black, and also we'll decrease the roughness so the floor becomes shiny. This way, we'll be able to clearly see the puddles we just created. Right now, we don't have wetness for our floors, which is why we had to adjust the roughness manually. So let's create a material function that we can add directly to the material. This function will automatically adjust the specular and roughness values to make the surface look wet. Let's create another material function and name it mf_wetness. With the magic of video editing, I've skipped the creation process. But let me explain how I made this function. First, I added 2 function inputs with the input type set to scalar. I named one roughness and the other specular. Then, I merged them using an append node and connected them to a lerp node. I also added a constant to vector node, setting the x value to 0.07 and the y value to 0.4. I connected this to the B input of the lerp node and then linked the R and G masks to the lerp output. Next, I dragged the output from the R mask and connected it to a function output. To create one, just drag a wire from any node and search for function output. I named this one Roughness. I did the same for Specular. I'll delete this since it was just for demonstration. Here I've added a function input for the base color, but this time the input type is set to vector 3. That's because colors use 3 channels. So we need a vector 3 to properly define the base color. Then connect this to a desaturation node and add a constant node with a value of -0.5 to reverse the saturation. We use desaturation instead of saturate because we're working with color values. With a negative value, desaturation actually darkens the surface, which gives us that wet look. while saturate only clamps values between 0 and 1 and wouldn't create the same effect. Now connect the desaturation node to a saturate node to clamp the wetness value. Then multiply this by 0.5 and connect the multiply node to the B input of a linear interpolate, or lerp node. We need two more function inputs. The first one is for wetness. I named it wet mask since it controls how wet the surface gets. The second one is for porousness. In simple words, porousness means how much the surface can soak up water, like the difference between concrete, which absorbs water, and metal, which doesn't. I named it wetness to make the function easier to understand. Now we'll use the wetness input function to drive everything. First, connect it to the alpha of roughness and specular lerp nodes. Then also connect it to the A input of our second lerp node. Finally, plug it into the A channel of the multiply node so we can combine wetness with porousness. Connect porousness to the B input, then add a saturate node to the multiply output, and finally attach it to the alpha input of the lerp node. Then drag a wire from the lerp node and connect it to a function output. This one is blue in my case, but that's just because it's the default function output. It works the same as the other outputs, so don't worry. Now let's go back to the parent material. I already have the function set up here, but I'll demonstrate it again for you. Drag and drop the material function into the graph. If I delete the old wetness function and apply the material, you'll notice the surface no longer looks wet. Now connect the material base color to the base color input of our function, roughness to roughness, and the wetness parameter to wetness. Take the constant, convert it to a parameter, and rename it Porousness, so we can control its value from the material instance. If you don't have a specular map, just attach any random value to specular. Finally, connect all the outputs of this function correctly. Once you apply the material, you'll see the changes directly in the viewport. In the material instance, we can now see both parameters, which we can use to control the wetness and porousness of the surface. For demonstration, the surface is looking wet. If I decrease the wetness value, the surface becomes less wet, and increasing it makes it wetter. The same works for the porousness parameter as well. Don't increase it too much though. Everything looks fine, but right now the rain particles are white, so let's fix their color. Also, the rain splashes are sliding along the x-axis instead of splashing upwards, so we'll fix that too. Double-click to open the rain system. In the velocity module of the splashes emitter, you'll see the cone x-axis value is set to 1. Change that to 0 and set the z-axis value to 1. Now we can see the splashes moving along the z-axis, which looks natural. Let's also change the gravity force from -380 to -480. Now go back to the velocity module and change the speed from 155 to 100. I think a velocity of 100 gives more natural looking splashes compared to 155. Let's fix the rain color. Go to initialize particle on the rain emitter and change the color mode to direct set if it's currently set to unset. Then lower the alpha value from 1 to 0.1. This will make the rain particles look more like real water. Do the same for the splashes emitter as well, to make the splashes look more realistic. Now we have a good realistic rain system with wetness and puddles. But before I end this video, I want to clarify something. If you remember the mask texture I used for puddles earlier, in my case, the puddle mask is stored in the green channel of the texture. That's why I only used the G channel. But if your texture has the puddle mask spread across the full RGB, then you can just use the RGB output instead. In this clip, you can also see the rain has ripples. I'll show you how to create ripples using either a Niagara system or material functions, but only if this video gets a good response, like around 1,670 likes and at least 65,000 views within 2 months. And I hope you learned something new today. Keep learning, and keep sharing these videos with anyone who wants to learn Unreal Engine with clear, transparent guidance.